Okay, in this video lesson we're just going to talk about the three main processes in which water will interact with substances to cause them to dissolve. Okay, so the first process that we're going to look at is the actual process of dissolving. This usually happens with polar substances. Polar substances which can dissolve in water because it's like dissolves like. Polar substances will dissolve in water, but do not break into ions because there are not full charges here. So one example of this would be methanol. So methanol is an alcohol and it's a polar substance, so as a liquid, and then when it dissolves in water we change the state of matter, so it's now an aqueous solution. Okay, so that's what the AQ stands for. Okay, so we're going to illustrate this with our water molecules, okay, as little v's. So the pointy end here is going to be the negative end because that's where the oxygen is, and the two tips of this V are the positive end where the hydrogens are. Okay, so if we think about it, methanol, if we're to draw the structure of methanol, Lewis structure, that's why we're spending some time looking at Lewis structures, because they help us understand why things will interact with each other. Okay, so oxygen, okay, is far more electronegative than hydrogen is, and carbon. So if we were to calculate the difference in electronegativities, oxygen has an electronegativity of 3.5 and hydrogen 2.1. So there's a fairly large dipole formed between oxygen and hydrogen. And then oxygen also is 3.5, carbon's 2.5, so there's a difference of 1. So this is also a decent sized dipole here. Okay, so the oxygen end is slightly negative. The hydrogen and thus carbon buried in a bunch of other hydrogens are both slightly positive ends. Okay, there are no dipoles between carbon and hydrogen because the difference here is, well, carbon's 2.5 and hydrogen is 2.1, so the difference is 0.4, so it's essentially zero, no dipole. Okay, so when it dissolves, water is going to have to interact with the methanol that comes into the solution in order for it to mix. Otherwise, if they don't interact, then they separate and they do not mix and don't form a mixture. Okay, so when that happens, if we were to again look at the structure, we've got oxygen here, which is slightly negative. Hydrogen and the carbon are slightly positive. These are the most accessible parts, the oxygen and the hydrogen. This carbon not quite as much, but still will interact. So if this is the case, what we'll have is these water molecules. The negative ends will be attracted to these positive ends of the structure. So we'll have a little oxygen attracted to the hydrogens here. Okay, same thing with this little positive end. We'll have water trying to interact with the positive end. And then around the oxygen, we're going to have the positive ends of the water molecule being attracted to it and surrounding it. And thereby, because of this interaction, we end up forming a solution, a mixture, because these particles can now start fitting in between the water particles. Okay? So that's what we generally see when a polar substance that doesn't have a full charge, just has these partial charges interacts with water, we have these dipole-dipole interactions. Okay? And so we can solubilize the solute as it comes in with water. Okay? Now, dissociation is the process of dissolving an ionic compound. So ionic compounds do something slightly different. Ionic compound dissolves in water by splitting up or dissociating into ions, which are full charges now. Okay. So if we were to draw that process in a chemical formula kind of way, it would be the sodium chloride compound is going to split into its individual ions. This is dissociation. Okay. We can also illustrate this using Lewis structures. So sodium is positively charged, chlorine, remember these are ionic, so they look like these structures here, minus, and when they separate into their respective ions again. Or, if we want to illustrate it in a little bit more picture way, we can kind of remind ourselves that this is actually just the formula unit for sodium chloride, because it really represents an array, a crystal lattice of positive and negative charges, alternating positive and negatives, attracted to the opposite charge, but they're separate particles, okay, attracted, so they're strongly attracted to each other, but they are separate particles. These would be the negative ones, full negative charges, like we would see with chloride, okay, and full positive charges, like we see with the sodium. I'm just going to illustrate a few of them. So the water molecules will be able to take apart piece by piece these different ions, because the ions themselves will interact pretty easily with the water molecules and surround them. Okay, remember water molecules have a negative end and a positive end. Positive ends. The negative end, which is where the oxygen is, that's where our oxygen is, it's attracted to these positive charged particles, the cations. Okay, so they surround them and interact with them and keep them separate away from the negative charges. If they can't interact with them and separate these ions, then those ions will go back together and they'll form a solid and they won't dissolve. That's the whole idea here. Okay? So it's necessary that the water actually will surround these and kind of neutralize them a little bit, or shield their charges from each other so they won't want to go back. And that's what's necessary when we have them dissolving. They have to interact with the water, and the water kind of shields those charges. So the point is where the oxygen is, so it's negatively charged slightly, so it's attracted to the positive ends, and the two ends of the water molecule, that's where the hydrogens are, so they're slightly positive, so they're attracted to the negative ends. So those are the two main ways that either a polar substance will dissolve in water, so the water interacts with the polar substance and the partial charges through dipole-dipole interactions, or there's a dissociation of the ions, and the ions interact with the dipoles, called an ion-dipole interaction, which are pretty strong. Okay? That's how we get things to dissolve. One last way that water will interact with substances It's forming ions called ionization. Okay? So some substances, when they dissolve in water, when dissolving in water, some molecular compounds can react with water. These are usually acids and bases to form ions. So it's the process of forming ions. So they aren't ions to start with. Okay. By the time they've interacted with water, they produce ions. I'm just going to show you a simple little example. So say we had hydrochloric acid, HCl. Okay, this is a molecular compound. Okay. And when water comes around, remember water's got a negatively and there's a slight dipole here. So there's a delta plus N and a delta negative N to this. So water's going to interact with this molecule. Okay? Remember, this is the delta negative end. So that delta negative end is going to be attracted to the delta plus of the HCl. But the other thing about water is it's got some lone pairs here. And those lone pairs are drawn towards the positive charge of hydrogen and can actually start saying that they'll form a bond between the oxygen here and this hydrogen. But hydrogen only likes one bond at a time. Okay? So if we can form a bond, start forming a bond between oxygen and hydrogen, we're going to break this bond between the hydrogen and the chlorine. And there's a little bit of a battle between these two parts of the molecule. Okay? And in this case, actually quite a bit of these molecules will actually undergo this ionization process. So now the hydrogen of the HCl is attached to oxygen, and it forms this structure here, which is no longer water, because it's got a hydrogen on there without its accompanying electrons, because the electron that came from hydrogen would be shared here and it went on to the chlorine. This becomes positively charged. So it's a positively charged polyatomic ion called the hydronium ion, and that is what's responsible for things being acidic or not. Okay. And then the chlorine takes that pair of electrons and accommodates it in its structure, because chlorine's pretty electronegative. It's pretty happy having that extra pair of the full set of electrons on its own, and it stays negative when it does that. Okay? So this is the process that we see happening when things dissolve in water that are superpolar and don't mind going from this neutral structure, okay, to separate ions. Okay, usually it's with acids and bases, and water is the main part of this process. It's reacting with the neutral molecule. Water's got the lone pairs. The lone pairs are available to form a bond. Hydrogen can't have more than one bond, so it'll break its bond with chlorine. Chlorine takes on those electrons, becomes negative, and when the hydrogen's attached to the water, this whole molecule now becomes a polyatomic ion that's positively charged called the hydronium ion. This is the process of ionization. So it's different than dissociation. Dissociation, they're already charged particles that just start interacting with water. when we have an ionization process, okay, water is actually reacting with the neutral polar molecule and forms ions out of it, okay? And that driving force is the fact that the chlorine's happy to have its negative charge because it's electronegative. It accommodates this formation of the ion because it doesn't mind being negatively charged, because then other water molecules can go around and surround it just like it did here. Okay, and that's the lesson there on the 3 different processes that happen in water to cause things to either be dissolved or some kind of reaction between water and the neutral molecule.